Okay, homework 2 is solving exponential equations. So for these equations, we had a 3-step process that was laid out in your notes. Step number 1 is to use the properties of exponents to simplify each side of the equation. What that essentially means is that the left-hand side should only have one base, the right-hand side should only have one base. So you can see like here, there's just a base of 9, here there's just a base of 9. Number 2, for instance, you would have to use some properties to combine up those two separate pieces. So for number 1, we're good on step 1. Step 2, rewrite the equation so both sides have the same base. You can see with number 1, they both have the same base already. So this one is pretty much ready to set up and just go right to step number 3. Step number 3, you drop the bases and set the exponents equal to each other. It's very, very, very important that you're not trying to do that step too early. The bases have to be combined on each side, and the bases have to be the same on each side. If those two things aren't true, then you cannot yet drop the bases and set the exponents equal to each other. But here, since those two things are true, we just go right ahead and we drop the bases and we set the exponents equal to each other. So that part is really, just something that we did in Unit 1, solving those equations. So when we set them equal to each other, I have a couple steps that I need to do. I'm going to start by adding this x to both sides. So 3x plus x is 4x. And then I'll add this 7 to both sides. So 5 plus 7 is 12. And then finally, I will divide both sides of the equation by 4. Okay, so I end up with that value as my answer. So that one, I started off with one that was pretty straightforward, didn't require much work. I next want to do number 7, because that does require some extra steps. So step 1, like I said before, is to rewrite, use the properties of exponents to simplify each side of the equation. So this left-hand side, you do have 2 bases as of right now. We need to simplify that up. So whenever you have a base to an exponent times the same base to an exponent, the rule says that you add those exponents together. All right, so when I add them together, I have 3k minus 1 plus 5k minus 7. So in my next step, I'll simplify that up. So I have, when I add my like terms, I have 8k and then minus 8. So that's what that ends up as. So that was step 1, making sure that I only have one base on each side of the equation. Step 2, rewrite the equation so both sides have the same base. This is a base of 2. 2 is a prime number. There isn't any lower that you can go with that. So that means you must be able to write 16 with a base of 2. And you can. You can take 16 and you can write it as 2 to the 4th. All right, so left-hand side is good. Right-hand side we can write as 2 to the 4th. So now we're good. Each side only has one base. The bases are the same on the left and on the right. Once those two things are true, then you can drop the bases and set the exponents equal to each other. And then it's just, a 2-step process to get that value of k by itself. So add 8 to both sides. 4 plus 8 is 12. And then divide both sides by 8. So we have 12 divided by 8, which you can reduce down by a common 4. So 12 divided by 8 reduces down to 3 over 2. Okay, I want to do one more example on the next page. I want to do number 12. So follow our 3-step process. Step 1, use the properties to simplify each side. There's nothing further that we have to do because there's only one base as of right now on each side. Step 2, rewrite the equation so both sides have the same base. So 27 and 81, you can trace them both back to a base of 3. So what you would do is the 27 you can write as 3 to the 3rd, and then outside the parentheses you would still have the exact same exponent that you had in the original problem. And 81 you can write as 3 to the 4th, and then same thing, you still have the exact same exponent on the outside that you started with. So back to the properties of exponents step, we have a property that says a power raised to a different power. You would multiply those powers together. So 3 times 3n is 9n. On this one, if I distribute the 4, I end up with 8n plus 4. All right, so the 2 steps are all set. There's one base on each side and the bases match. So once that is true, we can drop the bases and set the exponents equal to each other. So I will subtract 8n from both sides of the equation. So 9n minus 8n is n, and that just leaves the 4 on the right-hand side. So that is our solution.